In the previous videos, we discussed about allied angles and different things, correct? Now, every trigonometric function has a particular graph which represents that particular function. Okay, now in this, some of you guys might be, you might know certain type of graph. For example, sine curve is one very famous curve, and it's also very easy one. Like when you say sin x, see, generally how we represent any trigonometric curve, we have two things. Okay, so we have y is equal to sine of x. So here one thing I want you to understand is this part. Y is equal to sine x. X is going to be the angle and y is going to be the value. So we have value and we have angle. Alright. Now in this case, first I'll show how to write the graph. Okay, then we'll look into the graph part. So when you have y is equal to sine x, as the value of x changes, y value correspondingly it's going to change. Alright. Now in this case, suppose say we start from the origin 0. What is sine 0? 0. That means we are at origin itself, no change. Now as we keep on increasing, suppose say we move to pi by 6. Pi by 6 is 30 degree and sine pi by 6 is half. So we have a value of 1 here. Alright, so then we have, this is going to be half. Sine pi by 6 is half. Okay, then 1 by root 2, sine pi by 4 is 1 by root 2. Then root 3 by 2 and then finally 1. See, what you're going to get is you're going to have a graph something like this. Then it comes down. Okay, but still it's in the positive curve. The reason is, remember in second quadrant, sine is positive. So the first and second quadrant sine is positive, and that is depicted by this particular part of the graph. Alright, then third and fourth quadrant it's negative, isn't it? So the next two part it's going to be depicted something like this. So this is 0, this is pi by 2, pi, this is 3 pi by 2, this is 2 pi. Now this is the sine curve which you must have seen in almost all the cases. Okay, in electricity, in so many cases, in sound, okay, oscillation, so many things. We use this particular sine curve. Fair enough. Now, how we get the sine curve? Now, I think you have understood. You take x as an angle, start substituting the value. So, for every value of x, you get a corresponding value of y. Mark the point, start to write plot the graph, basically. Okay, so how an original in the sense how a proper sine curve is going to look like, we'll look into that now. All right, see, this is a sine curve. Now here we start from 0. As you look at this, the value, see, for pi by 2, this is pi by 2. So here you move like this, see, the value is 1. What is sine pi by 2? 1, right? So for pi it is 0. For 3 pi by 2, see, it is minus 1. Now, one thing I want you to understand. See, this is the first half in the sense, in that sine 1 full sine curve, this is 1 quarter. And this particular value, okay, this represents the first quadrant. Okay. And the next part, that means, see, this part here, what you're looking at, this particular part represents the second quadrant. Okay, first quadrant, second quadrant. Same thing, the third and fourth quadrant sine is negative. Correct? But what is sine of minus x? If you remember, sine of minus x is equal to minus sine x, right? And that is what is represented in this particular part, sine of minus x. That's why this is going to be negative. So this, whatever you are seeing, this is basically the sine curve. Okay, the most famous sine curve is this. One more thing is the values repeat. Correct? It's not unique. The value is repeating. Second important point, it's the takeaway from this particular graph, you can say. See, the first point is the values repeat. It's not unique. Okay. The second important point is, see, the maximum value. Maximum, whatever point you take, the maximum is 1 and the least value is always -1. That means the sine function ranges from -1 to +1. Always, irrespective of what value you have. Because we are looking all the way till 4 pi, 5, 6, 7, take 1000 pi also. The value is not going to be more than 1 or not going to be less than 1. Alright, that means here, so -1 less than or equal to sine x less than or equal to 1. The value is always between -1 and +1. Okay, this is another very, very, very important point for sine curve. Clear? Now that you have seen a sine curve, so I want you to see this part of the sine curve, this part of the sine curve. Because next we are looking to cosine. Cosine is what? Complement of sine, right? That means there is an offset of 90 degree or pi by 2. And see how the graph looks like for a cos curve. This is the graph for a cos. See the value. Remember that origin and pi by 2 points, two things which I encircled? Don't you think if you just shift the sine curve, you are going to get cos curve? The values are the same, see? Maximum is 1, least is -1. The values are repeating. The only difference is sine starts from origin, cos starts from 90. 90 in the sense, maximum value of 1. Sorry, not 90, maximum value of 1. That means here, the cos curve starts from 1 rather than 0. Now, again, we look into the other parts. In first quadrant, cos is positive or negative? It's positive. See, 0 to pi by 2, it's positive. See, this is the first part. And this is going to be the first quadrant. Second quadrant is cos positive or negative? Second quadrant is negative. See, that's why from pi by 2 to pi. So if you draw this one, pi by 2 to pi, this is the negative part, isn't it? See, it's below the axis. This is the second quadrant. This is the third quadrant. See, fourth quadrant, it's in the positive case, isn't it? Again, two things here. Okay, so one is it's going to be repetitive and you can say continuous. See, the same thing goes for sine curve also. It is continuous and repetition. Okay, these are what we call as harmonic functions, which you guys will learn about this later. Okay, and the second part is what is the maximum and minimum value? 1 to -1, right? So here it is always from -1 to 1. Okay, -1 to 1. So sine and cosine both are pretty much the same. It's just that there is an offset of 90 degree or pi by 2. That's all. Nothing more, nothing less. Clear? This is for the cos curve, what you guys have to know. Now we'll go for the next trigonometric function. The next one is the tan curve. Okay, see, this is the graph of tan. Now it looks very weird. It's not like sine or cos where you can easily draw it. Now this is a discontinuous graph. Because what is tan 90? Tan 90 is not defined, right? Now you start from 0. Tan 0 is 0. Now again, we'll look into the quadrant part first. 0 to 90 is first quadrant and tan is positive. So that is given by this entire thing. See here, this entire thing. This is the first quadrant here. Okay, where do I write it here? We'll write it here. This is the first quadrant and this is positive. Okay, now in the second quadrant, it's negative. But if you look at it, the graph keeps on going. Does it ever touch the 90 degree line? It can never touch because it's not defined, right? It's not a particular number. keeps on going closer and closer and closer, but it's never going to touch. That's why these type of lines, they have a special name. All right, so these type of lines, this is what we call as an asymptote. Asymptote. Asymptotes are those lines which the curve will be closer and closer and closer to the line, but it's never going to touch. It's never going to meet. Those lines are called as asymptote. There are many examples. Tan x is one. Okay, and the other things you will see. Apart from that, we also have 1 by x, inverse function, log x, e power x. There are so many cases where you can see the example of an asymptote. Okay, anyway, that's not the point here. See in this one, first quadrant, it's positive. Second quadrant, tan is negative, right? So in this case, second quadrant is from 90 to 180, which basically is this part. See here, this part. This is going to give us the second quadrant. Again, third quadrant, tan is positive. See, third quadrant, this is the positive part. Positive part. Anyway, so now here, what are the takeaway from this particular graph? Let's look into that. Now that you have understood why the tan curve looks like this. Again, one more thing is, what is tan of minus x? Minus tan x. That means here, less than 0, it comes in the negative case. See here, this is the negative part. Clear? Anyway, so the first part here, it's repetitive, definitely. So it's going to repeat and it is discontinuous. It's going to repeat and it is discontinuous. Because once you draw one graph, you have to lift the pen or pencil. Again, you have to draw. Correct? So this is going to be discontinuous. And here, see, it starts. Do you know the least value? Because it keeps on going less than, less than, less than, less than. So it's minus infinity. Correct. So we say that minus infinity is less than tan x is less than plus infinity. That means tan x has infinite range. That's why in many practical cases, we use tan x in finding the angle, not sine and cosine. Clear? So this is the graph of tan x. Now let's look into the next trigonometric function. The graph what you're looking at is secant x. Okay, so this is the equation of y is equal to secant x or secant theta, whatever. Now, secant is positive in which two quadrants? First and fourth quadrant, right? So here, first quadrant is 0 to pi by 2. See, this part becomes pi by 2. This is minus pi by 2. First quadrant, see, this is positive. Now, fourth quadrant, you can also write from 0 to minus pi, correct? That means what I'm trying to say here is that if you take the quadrant 0, pi by 2, pi, 3 pi by 2, correct? This is pi, 3 pi by 2. Now, you can also write the same thing in another way. That is, we can also write this as minus pi by 2, minus pi, minus 3 pi by 2, isn't it? That means 0 to minus pi by 2 is the fourth quadrant. Now, look at this particular graph. 0 to minus pi by 2, what is it? This part. Fourth quadrant, positive, isn't it? So, fourth quadrant is positive. And the second and the third quadrant, both of them are negative. Look at the graph, what you have. This is the second quadrant, pi by 2 to pi. This is the third quadrant, which is pi to 3 pi by 2, this case. Correct? Now here, what is the takeaway from this particular graph? Because now that we know, fine, this is how it's going to be. Very first point, is it continuous? No, it's not continuous. Is it repetitive? Yes, it is repetitive. That means the first point what we can write is that it is repetitive and discontinuous. Correct? Now the second point. Let's look at the range. Now it starts from 1, correct? 1 and then it goes to infinity. Again, remember asymptote pi by 2 and here also minus pi by 2 or odd multiples of pi by 2. It's an asymptote. See this pi by 2, 3 pi by 2, next 5 pi by 2 or minus pi by 2, minus 3 pi by 2. They all are the asymptotes. Fine. That means in this case, it starts from 1, goes up to infinity. And even in the negative scale, you have minus 1 to minus infinity. So that means between that minus 1 to 1, you don't have any value, correct? Look at the graph. It comes down, reaches 1 and then goes back up. Then from minus infinity it comes up, minus 1, again go back. It will go back. From 1 to minus 1 there is no graph whatsoever. That means you can say the range of this particular function. I'm deliberately not using the word range because you need to understand the actual meaning of range. Okay, for now you can just tell whatever that particular area where the secant x is going to work or wherever secant x is present. All right. So in this case, it is greater than, see, one is less than, one is greater than. Two cases are there. Correct. So first case, it is between 1 to infinity. Correct. That is for sure. That means in this case, whenever you have secant x, now secant x is lesser than 1 to infinity, less than or equal to 1 to infinity, and also it is greater than the negative part. So that means this is greater than or equal to minus 1 to infinity. So you can write minus 1 to minus infinity. This is going to be the case. So for secant, this is the range or this is the part where secant x will work. And you understood how the quadrants and positive negative is going to be. Clear? This is for secant. Now, the next one is cosecant, complement of secant. Right? Offset of 90 degree, offset of pi by 2. Just look at this particular graph carefully. And now you will see the next graph. See this particular graph. This is the cosecant graph. Okay. So for cosecant, again, what do we have here? See, this value is going to be pi by 2. Okay, which we have not shown here. Okay, this is going to be 3 pi by 2. This is going to be minus pi by 2, minus 3 pi by 2. First quadrant here, pi by 2 to this part. This is positive. Second quadrant is also positive. Correct? Third and fourth are negative. You can clearly see that the third and fourth are negative. This is the easier part. Okay. Again, you can see the asymptotes also. Y-axis itself is an asymptote. And pi, even multiples of pi. Okay. Sorry, not even multiples of pi by 2. Or you can say the natural multiples of pi. Natural numbers like 1 pi, 2 pi, 3 pi, 4 pi like this. Integral multiples also you can tell. Because we also have minus pi, right? That's what. Now, whatever the values we are looking at here, the graph, whatever you are looking at, now that you have to do two things. It's very similar to secant. Okay. The first is it repetitive? Yes. Is it discontinuous? Yes. So the first takeaway from this one, this is repeating and it is discontinuous. Second point is we need to look at, okay, what is the range for this one? Correct? Again, I'm using the word range. That's okay. We'll figure out what is the range of this particular function. So for cosecant x, for cosecant x. Again, the least value in the positive side is 1, and it goes all the way to positive infinity here, isn't it? And in the negative scale, the maximum value is -1, and it goes all the way down to minus infinity. So cosecant x, it is lesser than 1 to infinity, and it is greater than -1 to minus infinity. Okay, now this is the range. Now here one thing which I should have told you in the last case itself, that can you see this big bracket, the square bracket? This tells us that it is included. This number is included. Okay, when you see this curved bracket, this means it is excluded. Okay, included, excluded. So this is basically what we call as open and closed bracket, which you guys are going to understand that in the next year. But anyway, now you can use this one. So this is the range, or this is the values what cosecant x can take. Fair enough? Now let's look into the last one. This is the graph of cot x. Y is equal to cot x. Alright. Now I think you guys can only tell me how it's going to be, right? So you guys can only very easily judge. From 0 to pi by 2. The first quadrant, it is positive. See this part, it's positive. And the second quadrant, this is going to be negative. See, it's below the x-axis. See, this is negative. Right? Third quadrant again positive. Fourth quadrant negative. Because it's the reciprocal of tan, isn't it? Now, the next part is what? Once you have this particular graph, look at the asymptote. Y-axis is an asymptote. Pi or minus pi, 2 pi. So all integral multiples of pi, they're all the asymptotes for this particular graph. Clear? This is the first point, what you need to understand. Now, after this, let's look at the points what we used to do for observations, whatever we used to do for every graph. First point, it's going to be a repeating graph, correct? Repeating and discontinuous. What is the value? What are the values this cortex can take? See, cortex, see, it's going from plus infinity all the way to minus infinity, isn't it? So there is no break in between whatsoever. So that means cortex can go from minus infinity to plus infinity. Every value it can take. Clear? Now, in this case, whatever we are going to see here, in cortex especially, it's just like tan x, isn't it? So one goes up, as in, see, tan x, if you look at the tan x trend of tan x, it's coming down from plus infinity to minus infinity. It's coming down. So these are the graph of all the 6 trigonometric functions. So if you look at it, the first 2, sine and cosine, are continuous, repeating. The other 4 are discontinuous and repeating. So overall, all the trigonometric functions are repeating, but only 2 are continuous. The rest 4 of them are discontinuous. And every trigonometric function has a particular set of values what it can get, like what we call as the range. Okay, every trigonometric function. Some of them have asymptotes, some of them they do not have asymptotes. Clear? So this or these are the graphs. Now try to understand how the concept of allied angles, the sign of trigonometric function, and how you can link those two with the graph. Like when you do sine of pi plus theta, you get minus sine theta. Or one example I'll show you with the cot graph itself. See here, suppose if you do cot of, okay, let's say we are going to do simple one, cot of pi minus x. Second quadrant, cot is positive or negative? It's negative. This is going to be minus cot x, correct? So 0, this is pi minus x. So pi minus x is going to give you a value somewhere over here, isn't it? Now you do cot of, let's say, minus pi minus x. Minus pi minus x is going to give you a value somewhere over here. And if you look at those two graphs, that means if you look at this graph and if you look at this graph, they are one and the same. That means cot of pi minus x minus cot x. That is nothing but the allied angles concept, isn't it? So all these graphs, whatever you have, they tell you which quadrant and what is the relation between them. Everything you can do it with the help of these graphs. Alright, so this concludes the graph part of trigonometric functions.